Good morning, everybody. Good morning, Gonzo.
Good morning, Greg. Good to see you, man.
Well, we're gonna have a lot of fun today. We've got a project, three projects to work on. This the topic or the title of this live stream is Agentic Coding Live: Three Data Projects, 1 Hour Infinite Chaos. So we're pretty pumped to do it. I'll get into the details of what we're going to be working on here shortly. But first, introduction. So I'm Greg Michelson. I'm one of the co-founders here at Zerve, and I'm joined by David Gonzalez, my good friend Gonzo, who is just an outrageously good fella. I said fella. And, and I'm super pumped to have him with us. Say hi, Gonzo. Tell us a bit about yourself.
Yeah, Greg. Yeah, so happy to be here. Yeah, we've done some really fun projects together. We've done some really hard projects together. Yeah, we've done a lot of work at like 3 a.m., which is always the best time to be working, right?
Yeah, that's
And
fact. Me
yeah,
and Gonzo
so
worked
yeah, I'm
at
super excited to be here. Excited about what you guys are building at Zerve.
Nice. Well, we'll get into it, and hopefully everything will go good. This is definitely one of those tightrope with no net type situations. But yeah, I think some of my funnest times were working on pandemic problems in the middle of the night with you at Data Robot, trying to figure out what in the world was going on and how we could help and all that stuff. So we'll get into some interesting problems here today as well. Nothing pandemic related though, fortunately.
Yeah, that'll be good.
So pop quiz, Gaza. Why don't you tell us a little bit about Zerve? We'll flip the tables. You don't work here.
Yeah, so
Uh,
so Zerve is it's a solution for doing data science, right? And doing, um, we can call it like loosely AI. Uh, I think the way to think about Zerve is, what if a data scientist uh, decided to build something that would actually deliver production code that others could engage with? Um, and I feel like you guys have done a bang up job. The solutions that kind of are in this arena have typically skewed very notebook centric, very much running. Even if it's not running strictly on your laptop, it kind of feels like it does. Um, and I'll try and keep it PG on this, on this live streaming. But the typical reaction to data scientist work from people who aren't data scientists is, what the hell am I looking at? And I think Zerve is trying diligently to be able to skirt that question and get to something a little more approachable, or quite a bit more approachable.
Now, your background is in engineering, yeah, or data
I back.
science, or
Oh, I wish I had my background. Like I've become a pretty workable engineer, but I'm a tragic case, Nick, Greg. My background is primarily stats. And so
oh, nice. Okay, a fellow stats guy.
so I spent a lot of time in. Got all the way up to 800 level stats courses.
Wow,
Didn't graduate with stats. I did actually evolutionary ecology of all things.
wow.
So a lot
Okay,
of
I
time.
don't know what that means. What is evolutionary ecology? That's a topic for another day. All
That's
right, so
another
we.
day. Yeah, no one cares about that right now.
All right,
I don't
so I
even care
should be
about it.
sharing my screen here.
Okay.
There it is. It's popped up. We're going to jump into Zerve here. I've put together a data set. It's interesting data. It's a parcel data from Salt Lake City or Salt Lake County. So Salt Lake City is a big city in Utah, and Salt Lake County is the county that it's in.
Yeah.
And so I put together this data set, and we're going to try and solve three problems in this data set today. So let me see if I can explain what they are. So the first one is called Who Owns My Neighborhood? And we're going to try and just explore this data set, filter it, aggregate it, visualize these property records. This data set is at the parcel level. So like the plot of land that a house or a business or a building might be on.
Mhm.
And so the first project is like, who owns stuff? Like, what does the distribution of ownership look like? We're going to kind of try and explore kind of an EDA type project. The
Yeah.
second one is called Corporate Landlords of Salt Lake County. So here we're
Mhm.
trying to look at, are there big institutions or organizations that own lots of property in Salt Lake County? And that we're going to try and do some like cleanup and normalization of the owner name and try and get that working good. And then the third one is called a Tax Fairness Explorer, and we're going to try and get a sense for who's paying higher taxes and how does that vary by determining, how does it vary based on like where you are in the county and stuff like that. Yeah. So it's interesting data. We've intentionally not looked at it before. So what I've got here is 3 tabs that we're going to try and solve all 3 of those problems. And the only work that I've done here is upload that data set. So we've already uploaded that CSV file into Zerve. And as soon as Gonzo clicks into these projects, we'll be able to see him in there. We'll see his mouse moving around and so on. But just to get started, I'm going to just talk to our agent a bit and say, can you load the CSV file and explore it and describe what's in it, please? Just some basic EDA. Now, Gonzo, have you gotten to play around in Zerve very much, or is this kind of a new?
This is new. Yeah, I went to a talk with you guys. Did log in one time. Yeah, but this is brand new. I figured, yeah, we'll give her a run, and it'll work out all right.
Thanks. All right. So the way the agent works over here is that it's going to present a plan. So it's telling us what the plan is. I'm just going to say approve. We don't have time to go into the details, but we could iterate with the agent on the plan. And so the thing about you've used ChatGPT fairly extensively, yes, Gonzo?
I do. Yeah, a lot of API work, but I do. Yeah, I work even in the front end a lot.
Okay, awesome. And any other agentic or
yeah, Anthropic's Claude as well.
Oh, you use Claude Code?
I do use Claude Code. And then I do run not production stuff, but I do dabble with a lot of locally running things, trying to get some like Gemma to work locally reasonably well for some projects. Yeah.
Gotcha. All right. And what's your sense of how all this agentic coding stuff is impacting the way people do their work in the data science space? Say.
Well, I think it's kind of hitting a different strata, right? So at the low level, I'm seeing it create quite a bit of uncertainty around junior talent. There's just a lot of froth in the system right now, and a lot of junior talent is, ostensibly trained to go write code for a living, and a lot of them are finding themselves faced with, do I want to be a product manager? Do I want to be some kind of, like working on product or working on analysis, but not necessarily writing code? Because I think a lot of organizations are pausing and seeing, well, how much productivity can we get out of AI with our current existing talent base? At kind of the mid-tier, when we talk about, I don't know, an experienced engineer, there's kind of the whole rash of YouTube and TikTok vibe coding, which streams really well, looks really good on screen. And if you follow that long enough, or if you try it yourself, you will invariably find yourself yelling and screaming at the screen, because it's hard to quote vibe code, meaning like, throw your hat over the wall and hope you'll get a production application on the other side. That's pretty unreasonable.
Do you like that term vibe code? Like, is there a difference
I
between
don't like
agentic coding and vibe
coding? I do like the term vibe code because I think it aptly describes a way of doing things. And I'm sorry my screen's freezing, but I think you guys can still hear me. So I think it's an apt description for not being very thoughtfully engaged with what you're doing and hoping that magic works, right? It's a vibe, man.
Yeah, no, I definitely think it's such, the first time I heard that phrase, I thought, wow, that's annoying.
And it is annoying. It's annoying to watch. It's annoying to do. And it's annoying if your teammates are doing it and you're trying to get actual productivity out of what you're doing. So I do think that most people who have figured out a real productivity boost, who've actually delivered anything, have left vibe coding in the past and are working very much at the agentic level, either directly or with something that compartmentalizes and discretizes a problem into finite steps, and then focuses on actually the steps working, not trying to just press your fingers and pray that one prompt will get you a solution.
Right. So what's the difference? I mean, these terms are not very well defined in terms of
Well,
like
so
vibe
I'm
coding
looking at
versus
kind of what
agentic.
you're doing here, and so
Yeah.
kind of the rudiments of my path from going from like, well, yeah, I'd say about a year. Yeah, it's been a little over a year. A little over a year ago, I think my engagement with LLM as a coding assistant. So, before that, I would say that I got, and still to this day get, a tremendous productivity boost around autocomplete. And autocomplete seems to get better and better and better with each iteration. And truly, like today, autocomplete is great. It writes more lines better, cleanly. So I think autocomplete's a fantastic thing. And it's kind of hard to tell what's behind the scenes on an autocomplete, but it is getting smarter. And so obviously there's a lot of systems where autocomplete is tied to an LLM. I think, if thinking about it almost like a video game, that's like, I would call that first person shooter version. Like, I'm right here, you can see the gun, I'm doing the thing, right? I think what people really want is, like, they actually just want to watch somebody else do it. They want streaming, right? They just want to they want to watch a Twitch stream of AI building software for them, right? That's what they really want. And that's really hard to do. It's doable, but for me, the process has gone from essentially replacing Stack Overflow with like an LLM. Like, that was a lot of my path, was just like, instead of going to Stack Overflow and pouring through a bunch of answers, sorry, Stack Overflow, I do love you, and I think you're a wonderful resource. But it's just a lot easier to go ask ChatGPT or Claude and say, hey, how do I write this bash script, or how do I do this thing, or how do I do this, flip of a data set, in pandas or what have you. Currently, I'm pretty close to kind of watching something build for me.
Right.
But it's required a lot of work. Like, I have a lot of infrastructure. I have my own agentic wiring of, I'm currently using a lot of GPT-5 and Codex. I do think Anthropic's Cloud Code is a phenomenal solution. And I think a lot of people are getting a lot of productivity out of Claude.
Gotcha. All right. Well, Agent has done a fair bit of stuff here. Vibe coding is definitely a bit more passive, and we've been a little passive here as we've been sort of chatting about.
We have, right? Yeah, but it's breaking it into smaller problems. Yeah.
Yeah. So, like, we're doing some basic data quality stuff. So it looks like the street dir, maybe direction. I guess it runs north, south, east, or west. And street type, those tend to be fairly missing, but everything else is relatively complete. So these are the top 10 columns in terms of like missing value percentages. Looks like we're doing no duplicate rows. So we've done some kind of basic data quality checks. This looks like unique values for categorical columns. So street direction, there's only 4 values. So that probably is north, south, east, west, though it's mostly missing. Only 1 value for tax class 3. So, some tax class 1 has 22 distinct values. So it looks like that's a nested structure in terms of tax classifications, maybe. We've got numeric ranges, so high and low values. They didn't print out very pretty here, but we could go and look at that in a bit. Looking at summarizing data issues. Let's see.
Something I want to call out here, Greg, is like, this is very introspectable. Right. This is very different from typing into ChatGPT or into Claude and saying, do EDA on this data set, which you can do. We can do that. And what you'll get is essentially a trace of everything that it was trying. It's all obscured for the most part. You can click into it, but it's pretty hard to look at. I think it's actually brilliant that the code that created it is right there on the left. It's very introspectable. It means that you can also riff as an individual. You can think through and reason through the problem a lot easier than just yammering at the LLM, like do it differently, and then
Hmm. I do
devolves
like
to
a good
swearing
yammer,
at.
though.
Oh yeah, who doesn't? Right.
So we've kind of gotten a flavor for the data. It looks like it still wants to draw some visualization. So we'll get a few blocks coming up here in a minute. But what's your sense of things? What's the next step here? If we were so this first project is who owns my neighborhood, and the thing that we said we would do is to filter, aggregate, and visualize property records to identify top owners, clustered holdings, and surprising trends, like multiple parcels owned by a single entity.
Yeah.
So
Let's see.
we should just ask the agent to
We
do
should
that.
just let's just ask the agent to do that and see what it does.
All right, we can
If it
have
doesn't
multiple
do a good
agents
job,
working
then
all at
we'll
the same
go.
time. So I'll just start a new one, and I'll say I just copied this right from the description of the description of the live stream.
Mhm.
So by filtering, aggregating, and visual property records, you can identify. I guess I should make that a question or a command. Identify top owners, clustered holdings, and surprising trends, like multiple parcels owned by a single entity. I'm going to say include visualizations and summarize findings. Period. All right. So we now have two agents cooking here simultaneously. We can switch back and forth, but we'll stick with this one. It's going to come up with a plan here to do its work, and hopefully they won't step on each other. Oh, we're doing some data visualization here, so let's dive in here. All right, so let's jump into. Let's get a better view of this guy. So we've got parcel acres distribution. Oh, that's interesting.
X class looks like it probably will be helpful.
X class? Where are you seeing that?
The tax.
Here, I'm going to click on your picture so that we can.
Yeah, so I'm over here at tax class.
Yeah, I'm just following you.
I don't know what those mean, but those are probably tie off to owner type pretty cleanly.
Yeah. Fair number. It looks like that bottom one is missing values.
Yeah, and then lot use.
Yeah, interesting. Okay, interesting.
Yeah,
all right, cool. So we'll let that one think. Let's jump to the next project. I'm going to say read in the. I suppose we could have done this all in one project, so we wouldn't have to read in the data set multiple times. Read in the CSV file and do the following. And I'll copy this one. The next one is called Corporate Landlords of Salt Lake County. It says this project uncovers the largest institutional property owners by cleaning and normalizing the messy own name field and then grouping parcels by total acreage or market value. Okay, interesting. So I'm going to paste that in here. So I'm going to change it to uncover the largest institutional property owners by cleaning and normalizing the messy own name field, then group parcels by total acreage or market value and visualize the results. So we'll get that one cooking.
Right, and I'm going to answer some of these questions we've got coming in the chat.
Good.
Yeah, so you're asking for like what skills and experiences should I focus on developing, right? And yeah, I wish I had a much better answer right now, but I'm going to say kind of the honest answer is it's really hard to know right now what people want in junior talent because we're trying to figure out real time how much can we task AI with the tasks that we used to task junior talent. And I know that's not a very encouraging answer, but I think that's the brass tacks reality right now. And so the skills you can develop, I think, are, and I'll frame it this way. I feel like I have to repent about 11 years of my career.
What do you mean by that?
Because I went on this quixotic quest to go democratize AI, right? I was like, I wonder if I can invent a thing that'll do my job. And you know what? I invented a thing, and then I sold that thing to a company that invented another thing. And it did a lot of data science's job, right? It built models. So I'm talking about the company I started was called Zerve, and then sold that to DataRobot, where I met Greg. And DataRobot does a tremendous job of doing a lot of the work of data science. But there's a bookend problem in data science, which is framing and scoping, and then organizational adoption. And everything in between is really cool, right? It's building models, it's interrogating data, it's understanding all that stuff. But at the end of the day, if you don't have a very well framed and scoped problem and you don't have a path to adoption, it doesn't matter how cool your models are. And that's why, depending on what stat you want to look at, X% of data science and AI projects fail because they weren't really very well framed, they weren't really very well scoped, and they didn't actually have anybody with the skills to do change management. Greg is a person who has tremendous skills of change management, like astounding skills of change management. He also happens to be a very reasonable data scientist. He's quite skilled that way.
Tell my wife anyway.
Yeah. But and so the reason I bring that up, AJ, is like, I think them's the skills, right? I think the skills of understanding either change management or understanding how to properly scope and frame problems are the things that allow you to ply your trade and do your craft very valuably. And without, so entry-level data scientists can punch way above their weight these days, and they don't cost a fortune either.
Yeah, that's fair. What about that?
It's fair on the technical side, but it isn't. I wouldn't say that it's fair on the part where the rubber hits the road. And you're kind of competing at the same level of like, well, I can punch into Zerve a prompt and get data out. And I would say, well, if you really want to figure out how to be employable, figure out how to do one of the bookend problems.
So you've got kids.
Yeah.
What would you tell them to study if they were interested in this whole field?
Oh, no one wants to hear my advice to my children.
Okay, not your kids, my kids. Who you think people should study computer science anymore? Is it worth doing?
Oh, I do think it's worth doing, but I think it's worth doing like getting a math degree is worth doing. Like, it really will challenge you. You will think much sharper. You'll have a very, very strong perspective on how things work, but you probably won't use it that much.
Okay, so it's kind of your chores type thing and learn like programmatic thinking, that sort of situation.
Can you become great like Greg from 2020 with agentic data science? No, you can't become like Greg from 2020. Not without. Again, now I would argue that Greg's true value that he brings to the table, on top of his very capable skills manipulating data, crafting, good information streams, finding good insights, building reasonable models, Greg really has paid the price in kind of his temperament, his orientation, the way that he approaches things. Greg sees that things get done. He really does. He's a person who's very, very driven to see that things that get done stay done, and that things that get done were the right things to do. That wisdom, some of the data tells you that, but most of it is Greg's, like temperament, wisdom, and honestly, just his proclivity to go, look, things that are shiny are nice, but if it doesn't stay done, who cares?
Well, given that I actually was Greg from 2020 at one point, I'm not. I don't know if that's exactly something to aspire to. Anyway, well, let's look at some results here.
Let's look at some results.
We've started to get some interesting stuff going on. So we've got about $6 billion worth of land that is owned by trust not identified. So we've got some missing data there.
Oh, it's probably the LDS Church.
Oh, you think so?
Well, maybe. If it's a lot of land, it's probably the LDS Church.
Wow, shocking. Well, that would be outrageous. Salt Lake City and Salt Lake County are the next two biggest landowners, and then the Utah Department of Transportation, West Valley City, the federal government. Oh, this is LDS.
Okay.
So they own $47 million worth of property, I guess, in Salt Lake County, 570 parcels. And then Kennecott Utah Copper Corp. So it looks like a mining company, maybe. Then a couple of more cities. Snowbird Resort.
There you go.
Big skiing place, right? But that's $127 million. So, okay, interesting results there. Let's get our third project kicked off. What do you think about the ownership stuff?
Yeah, that was great. That was what, 3 prompts to get there. That's pretty ridiculous, man. That's pretty good.
All right, next one is Tax Fairness Explorer. It says this analysis explores fairness in property taxation by comparing taxable value against full market value across neighborhoods and visualizing which areas pay more or less tax per dollar of market value. Okay, let's look at that. That's interesting.
Yeah.
Read.
And player one, yeah, absolutely. I think you're seeing, like, this CSV is what, 188 megs?
It's a decent sized file. Yeah.
It's decent sized, right? And you can go larger, right? Zerve can handle larger. So yeah, definitely Zerve. I think, AJ, again, kind of coming back to your question, because I think it's a very important question. So I'll share with you something that one of my favorite engineers, Lance, said about 3 months ago. Lance is a very capable full stack software developer. He's got a math degree, right? So he's very, very sharp. And he's been doing software development for 27 years, I think.
Okay.
3 months ago, Lance had an epiphany, and his epiphany, Greg, was, okay, so writing code by hand is a premature optimization at this point and where we're at. And he'd been suffering through a lot of our agentic work, a lot of our LLMs, and resisting it, frankly. Just kind of like, look, I know how to write code by hand. And he was doing kind of the Stack Overflow thing. And then something clicked. We started working with PRDs and decomposing our problems into smaller things and finding that the LMs were doing a really good job at small problems, right? Like piecewise. And think enterprise software development. So these are pretty sprawling problems. Analysis is a little more directional. Yeah, and so I think tools like Zerve really step on the gas of writing code by hand is a premature optimization. No longer is every keystroke precious, but you still need to understand and kind of reason through the problem really smartly. And I do think that with a data science background, that's going to be easier for a lot of folks to see.
Okay, top 20. So I've gone back to the first project. I had the tax fairness project kicked off now. The name normalization stuff is cooking, and you can see some of the stuff that it's doing. It did, it's like fixing comma LLC and normalizing it to no comma, that sort of thing. So it's removing those kinds of suffixes, and this one was replacing the ampersand with the word and. So
okay, so we got a normalization.
Yeah, so we're trying to
rationalize this data set a bit. Yeah,
spelled differently, that sort of thing. And then it's summarizing by the the biggest owners again. So we're seeing a lot of the same results, but I think once you get down into the smaller, less prominent ones, that you'd start to see some differences from the previous analysis. And then I kicked off the Tax Explorer one as well. One thing I would say about the big data set question is that this is all running in the cloud, and it's all running serverlessly. So when each of these cells actually, or not cells, each of these blocks actually runs, it's spinning up compute on the fly, and you have some control over what compute is used. So by default, we use Lambdas, which are the fastest. They're a bit limited. AWS has a hard limit of 15-minute runtime on the Lambdas, which is more than enough for most things that you're going to run. If you do need bigger stuff, you can always pick larger compute types. You can use GPUs and so on. So if you do need, if you're training a neural network, or if you've got something that needs GPUs, you can go down that road too. So you can get pretty chunky bits of memory if you're dealing with bigger data. But then if you've got like huge data, then you have the same problem that you'd have anywhere else. So like if you were trying to analyze 10 gigs of data or 100 gigs of data on a Jupyter notebook locally, you'd have a pretty hard problem. So you end up doing sampling and stuff like that.
Yeah, that's right. And then you actually have to reach for your toolkit, right?
Yeah, right. Exactly.
Yeah.
Exactly. All right, let's see here. What do you talk to me about production? So you've done a fair bit of work, Gonzo, doing moving notebooks into production, moving data science projects into production.
Yeah.
How's that go for you?
Yeah, well, let's kind of go through the experiences. Moving notebooks to production sucks. Like the one of the worst handoffs in the world is I built this notebook. It runs on my laptop. Can you get it in production? Um, yeah, and it sucks because they're not a terribly production worthy uh, artifact. They're mostly, I mean, literally the name is notebooks. Like that's what they are. They're a place to think through and reason through problems, right? But they haven't been designed, and they still continue to struggle to be usable as a production artifact. And so then, and here's one of my favorite horror stories of getting a notebook into production. Getting a notebook from one of my favorite data scientists and struggling for 4 hours to get the damn thing to even run. Like I'm looking at it like what it is it. It was kind of a messy, right? It's kind of a messy thing. And so I'm trying to get the thing to run. I finally get to a point where it's kind of running, but I still don't know what the dependencies are in this thing. And I'm trying to reason through it from the code, like back into what these, because it didn't come with a requirements.txt file, didn't come with any of that, right? I finally went back to the data scientist and I said, "Hey, can you help me, figure this out?" And he's a dear friend of mine, lovely human being, kind of scattered, right, a little scattered in his approach. Right? So he shows me it running, and I'm like, okay. And then I see it's running in System Python. I'm like, okay, not the best practice, but that's fine, whatever. And I said, would you type in pip freeze and output the result to a requirements.txt file? And folks, I've never seen pip freeze take a minute. Like it's a very fast process. And this thing kind of stalled for a second. I'm like, uh-oh, that's not a good sign. And the requirements.txt file that came out had thousands of lines of dependencies. So he'd been working in a single environment for many years, and it just had a lot of cruft in there. And so we had to decide how we were going to go about this. And that kind of leads to the second thing. It's like, well, how else can you deploy something? Well, you could spin up a Docker container, build the whole thing in Docker, snapshot the Docker container, and ship it over. Same kind of problem applies, right? I've received and I've embarrassingly shipped Docker containers that were several gigs, tens of gigs, that probably truly ran about a few hundred lines of code. And that's a disproportionate weight, right? 400 lines of code that takes 10 gigs to run. That's not a very efficient scenario. Yeah, and then I've also shipped things using platforms like DataRobot. I've shipped things using some open source tooling. I shipped a model in H2O years and years ago. I shipped a model there. Yeah, I think at the end of the day, the problem with shipping models is that it's kind of an afterthought. And so you end up finding yourself kind of hamstrung between, the individuals who did the analysis and did the work, and the people who are going to be responsible for keeping it running. And they're not, even today in 2025, most DevOps and SREs and QAs are not, they're not expert enough to know how to inherit something like a notebook or even a model for that matter, because it's a probabilistic kind of thing. It comes up with a bracketed prediction, when that's kind of the deliverable, or it comes up with visualizations that don't run as React components or other. So there's a fair bit of issues, right, in getting things into production. So what's really nice is to have an opinionated architecture. Honestly, like that's a really nice thing to have.
Do you think that the large language models will start to help with the deployment stuff? Because data scientists aren't trained in that. So there is that kind of handoff. Like there's, I have a PhD in statistics, and we didn't even think I never even heard the word DevOps until I was working at DataRobot.
Oh, right.
Which was many years after I graduated and had been working out in the industry. So is that something? Are there any tools out there for AIing DevOps?
AIing DevOps. Not that I'm super familiar with. I'm not a DevOps expert, right? I know that you've got, a lot of the SaaS data science platforms will have some kind of deployment strategy or some kind of
Mhm.
opinionated architecture.
Mhm.
Um, yeah, and then there are like Google Notebooks has I can never remember what they call their AI studio.
Colab?
They
Oh.
Colab, yeah. There's Colab, there's SageMaker. A lot of
Uh-huh.
those you can essentially surface an endpoint after you've built something. You kind of tell it this is the cell and this is what I want, and then it'll surface an API endpoint, which is a pretty reasonable thing to do. I don't think it's the worst. Um, they do have some production problems, like where's the logging, where's the failover, right?
Right.
Where's the stuff that we care about?
Mhm.
So yeah, so it's I don't think the situation's awesome in 2025, but it's definitely better than it was 10 years ago.
Hmm. Okay, let me dive in. Oh, these two are both done now. I think it says it's finished.
Sweet.
Looking at both of these guys, here's a summary. That's interesting. I don't want to read the summary. That's too much reading. That's a TLDR type situation. But I did see a plot here that had it showed that in fact that trust not found guy that
Yeah,
actually was the Mormon Church. So that's interesting.
that
So
doesn't surprise me in the least. Yeah. How did it find that? Yeah.
the vision. Well, there was an owner name field. I think that I don't think it was using here.
Oh, okay.
Let
Oh,
me
there's
zoom out here. We've
where are you at?
built
Let's
a
see. I'll go
fair
find
bit
you.
of visualizations here. Let me see if I can find where that was. Here it is.
Okay, I see you. Yeah.
Yeah. So here's our plot. So yeah, the LDS Church, the Mormon Church, is by far, by
I,
a factor of almost 10, the biggest landowner by value, followed by
yeah,
200 South owner. I don't know what that is. Fashion Place is a shopping mall, right?
that is a shopping
I
mall.
think it
Yeah.
is. City Creek is another shopping mall.
Which is
So
owned by the LDS church as well, City Creek.
is it really?
Yeah, the mall. It's $1 billion mall built by a church. It's fantastic.
Wow.
It's a beautiful
That,
mall.
that's wild. I had no idea. so, so anyway, that's fun. So I'm going to skip to this one because I think that the agent's actually having a problem
Okay.
figuring out what's going on here. So we got in here and we loaded in the data, and then we've got the distributions here, and we've identified some columns. So
Mhm.
like taxable value, total full market value, adjusted and assessed value, tax districts, that sort of thing. It's not quite done with its work yet. It's still working on fairness comparison, visualizations, and insights. But the thing that is bugging me is that all these values are the same. So like the total assessed, total adjusted, total full market value. Oh, they're not the same either. So the averages are
Mm.
different. They're the same for adjusted versus assessed. So these two variables seem to be duplicates of each other. But these two are
Mhm.
different. So full market value versus taxable value, those are very different. So that's interesting. So there may not be a problem there. This is just counting missing values. This is sample records. Maybe that's not so interesting. So we have tax burden calculated for 98.3% of
Of the
properties.
properties. That's cool.
So let's go into summary stats. Mean tax burden. So how
Is this
did we
like a mill
define
rate? What
tax
does this
burden?
mean?
Here's tax burden. Tax burden. Let me dive into this mode here and just resize some windows. So tax burden looks like it's full market value. So you have to have a non-missing full market value greater than 0. And then you divide taxable value by total full market value.
Yeah.
So taxable divided by total full market.
So we
And
are going
that,
to probably have some issues because people aren't required to report their market value.
but that's interesting. So the average taxable value is 55% of the total market value, and the standard
Okay.
deviation is actually pretty wide.
It's really
Uh,
wide. Yeah. Yeah.
so you have some where they're the same. You have some where there's 0 taxable value. I guess those might be like government entities and that sort of
Or
thing.
just unreported. It could just be unreported too.
Yeah, that's
right?
true. That's true. I guess I don't know. It seems like you'd have a taxable value. But then for the biggest ones, it looks like our tax burden is 1. So that's interesting.
Mhm.
So maybe for the biggest districts, those are all like owned by governments and such.
Well, we
And
just
then
saw
these
that.
ones, go
Yeah, we
ahead.
just saw that most of the property is owned by the LDS Church, which is non-taxed.
Oh yeah, that's fair. But they would have to pay property taxes still, huh? Don't you think?
I don't know. I don't know
I,
how
yeah, I don't know what either.
churches work.
Oh, I can see also we're going to have an issue here because these neighborhoods are just numbers, so we're not going to know what they actually are. But
Mm,
there's some neighborhoods that are have a very low taxable burden, which is
yeah,
surprising. Wow, this is actually pretty surprising that the tax burden would be like less than 10% for all of these guys,
yeah.
whereas it's like 100% for this crowd up here. So that's interesting. I wonder what that difference is.
Mhm.
Probably one maybe next step for another day would be to figure out the mapping because there's no lat longs in here. Like
There's
there's
no
no way
lot
to
lines.
actually
Yeah.
plot the parcels to be able to kind of figure out where draw a map and identify like the rich
I mean, this is
neighborhoods
great.
versus
This
the
little this summary on the output. That's great.
yes. This is properties in the neighborhoods. This would be the size of the neighborhood versus the average tax burden. So that's I suppose that's interesting. There doesn't seem to be any correlation there.
Mm-mm.
Maybe more, well, certainly more variability for smaller neighborhoods than for bigger ones, with the average being pretty common.
Pretty
So it looks
common.
like
Yeah.
most of your properties are taxed at about, I don't know, 55%
Hmm.
of their total full market
And so
value.
yeah, and I think
That's,
that's right. That's fair.
I suppose that's interesting. So 805 neighborhoods analyzed. Highest burden neighborhood is number 7880, but there are a fair number that are at 1, and then there are
Mhm.
some that have 0 taxes. So that'd probably be worth digging into. Probably a next step. Oh, you know what we could do? Let's start a new one. Oh well, it finished here. So for neighborhoods that have 100% tax burden and 0% tax burden, can you list out the largest, the most common owners of
Mhm.
these parcels? That might be interesting to look at. That would certainly kind of verify your hypothesis that maybe the Mormon Church is tax exempt in some way. I
Mhm.
suppose it would have been good research to like try and figure out what the actual rules were around taxation before we.
Or we can just infer them and see if we
Yeah,
believe
totally.
it.
I'll say okay. So here's just a summary of the analysis. This is a markdown.
Yep.
Let's see. Key findings:
Yeah, that's what I was
extreme
looking at.
geographic
Yeah.
disparities. Start that plan. So there are highest burden neighborhoods, meaning properties pay taxes equal to 100% of their market value annually. Lowest burden neighborhoods show 0% burden, paying no tax relative to their full market value. So the difference the difference between highest and lowest burden is effectively infinite,
It is. It's effectively.
indicating fundamental inequities. Median tax burden 55%, the standard deviation. There are 21,000 zero tax properties, so 5% face no tax burden at all. Those has to be government entities.
Gotta be right. It's got to be like Utah State.
And I wish it would have said the value here, not just the count,
Mhm.
but also the value and the percent by count. That would be interesting. We could ask that after. Roughly balanced split between above median 411 and below median 417. Well, you'd expect that. It's called the median. Neighborhoods facing higher tax burdens. Oh, here's your market values. So these are interesting in the 5 lowest. So the numbers aren't wildly different. 20 million, 20 million, 300 million, 360 million,
Mhm.
499 million. And these 2.6 billion. That's a big neighborhood. That has to be the church, I
That
guess.
has to be. Yeah, that has to be right downtown or something.
Fairness concerns, extremes, outliers, zero tax properties, geographic clustering. The wide variation suggests that where you live significantly impacts your relative tax burden, independent of property value. There's an inverse relationship possibility. Some lower burden neighborhoods have higher total market values, suggesting higher value areas may face proportionally lower tax burdens, a regressive pattern. Well, that doesn't seem fair. And it gives us some recommendations to identify the extreme cases, which we actually just kicked off. So there might be some blog showing up on that. There are review exemptions. So there are 21,000 zero tax properties. Geographic study. So this would be like the mapping that we already talked about. And the conclusion. So all this data, by the way, is completely public. I just downloaded it. I actually use the API. They have a pretty slick API to download the stuff. And so let's see here. Well, we're diving into. Okay, this is the 100% tax burden stuff. Let me shrink our font a smidge. Looks like Kennecott Copper Corporation, Lakefront Gun Fur Reclamation Club. This is just a person. So some people, it's not just the really big properties. Let's look at some
individuals.
Here's the zeros. Okay, so yeah, these are government entities. So
there you go.
Division of State Lands, Lands and Forestry. Yeah, so these are NAN.
NAN, yeah.
There's some data cleanup issues there. Yeah, so it looks like the zero tax burden ones are government entities. So the 100% tax total market value is 69 billion, and the 0% tax is 47 billion. So that's interesting. Huh. Okay, so lots of cool stuff going on there. All right. Anyway, I think it's pretty fair to say that we tackled these problems pretty successfully.
We did, yeah, in short order, like in relatively short order.
A little diving in to see what's going on there. But I did want to have a look at some of these questions that have been coming in the last 10 minutes that we've got. There's certainly some interesting questions. Let's see. Rendell says, can I connect my own data sources, or does everything have to be uploaded? Yeah, you absolutely can. You can connect to Snowflake or Databricks or MySQL, or we have lots of connectors that are already built, or you can just connect by code. So like anything you can do with code, you can connect directly. You can use S3 or wherever what it would be. So real easy to connect to other data sources. And then we've got Namdi, who says, how does the agent decide on the granularity, i.e. how much code goes into one cell? Good question. It tends to err on the side of more modularity than less, which is a smart thing to do, I think. One of the characteristics of the way that Zerve works is that it's like every block is kind of like a checkpoint. So all the outputs are serialized and stored at every point. So you'll notice, like, we were in my screen and Gonzo was in there as well. He didn't have to run that code in order to see those results. He could just go in and look at any block and see the inputs and the outputs and visualize what they might look like and all that kind of things. And he could write code and run code and so on. So more modularity tends to be better when you are like debugging, and when you're writing, so that you can kind of look and see along the way. So when I'm writing the code, I generally say, all right, whenever I want to look at stuff, that's a block. And then the next block might run some code, and then I'd look at stuff again. That's how I think about it. Depends on the day with the agent. I mean, sometimes these agents are a bit unpredictable, but the agent, like I said, tends to err on the side of more modularity versus less. Also, the agent can see, you may have noticed as we were watching this thing go, the agent can see the output and the data and the code. So it's got full context into the problem. So that's a big difference between like, like a cursor or something like that, where you have to teach it the data. Like if you were trying to do this in ChatGPT, you'd have to like paste in the output and show it what actually happened. And then it would get the variable names wrong. And so you're like correcting that stuff and so on. So you could do something like this with the ChatGPT, but it doesn't have your context. So it actually ends up being kind of a pain to use. Let's see. Next one. Do I need to install anything locally, or is everything browser based? Yep, everything's browser based. We're cloud native. This was running in AWS, but we can install on any of the cloud environments. We're actually designed to be self-hosted. People's data tends to be sensitive, and so they don't want to be shipping their data out to a third party in some cases. So the install on AWS is actually really straightforward to do. So you can get self-hosted, and then your data and your compute live in your cloud, and we help manage orchestration. Okay, do you see any interesting ones? Oh, are there academic or student licenses? Yeah, actually there is. You can get, well, everybody can sign up and use Zerve for free and get 5 credits a month. The academic and student licenses, if you verify your school email, gets you double credits on that free tier. So you get 10 credits instead of 5, which is great. So all the students should definitely jump in.
You guys got Git integration, don't you?
We do. Yeah, we integrate with Git, GitHub, or Bitbucket, or any of the big providers of source control type stuff. So yeah, you
so
can.
Yeah, there's version control. Yeah.
Oh yeah. So we have that. We also got some rollback features. So like if you were using the agent and you want to like see what it did and undo those kinds of things, in the notebook view that we'll be releasing pretty soon, you can see those and kind of approve them before things go. So we used kind of the scorched earth approach when working with the agent today. We were like, just solve this problem. But that's not the only way to work with the agent. So you might want much more fine-grained control and say, look, in this cell, this is what's happening. This is what I want to happen. Just change this cell or this block to do your bidding. So like that kind of stuff is completely doable. But we didn't do any of it today because we were just kind of like, throwing
YOLO, right?
a hand
YOLO,
grenade
yeah.
into the problem. Let's see, one more. How do you ensure that agents understand the real impact and importance of visualization outputs while keeping stakeholders' perspectives and needs at the forefront? Gonzo, you want to take a crack at that one?
Yeah. Again, you're going to have to do that work, right? Like you can have it cough up a bunch of stuff, but at the end of the day, if you want stakeholders' perspectives and needs at the forefront, then you're going to need to articulate what those needs are. I don't think you necessarily have to handicraft every visualization, but if they need to understand certain dimensions of the data, or if certain comparisons of information are going to be more insightful and drive to more decision clarity, yeah, then you just need to make sure that that's in the prompt that you're doing. I think, right? I think it'll do a reasonable job, and you can see, right? Maybe it'll suck, but I don't know. Watching what we watched today, I think we can bet that it's going to do a pretty reasonable job if you articulate any constraints.
All right, and we've got about 5 minutes to go. I think we'll close on the questions there, and just thank you, Gonzo. This was really fun.
It really was fun.
What are your closing thoughts on this? Was it what you expected? Did you expect it to go the way it went?
I mean, I kind of did expect it to go the way it went because, I've been working on this stuff for a while, and I've been really impressed with what you guys have built. And so I kind of thought, well, if Graves got any thumb on the scale of Zerve, and it seems like he does, it's going to do a lot of the work that is tedious to do. And it did. It did a fantastic job. I love how modular everything is. I love how everything's broken out. I love that the code is available and visible and introspectable. Yeah, I think you guys have built something that, frankly, I would happily advise any level of talent to try and see if they can make it really workable in this system, especially if the alternatives are they're hammering on a notebook running locally. I'm like, please just stop. Just stop doing that. It's not that helpful to you. It's not that helpful to others. There's some exceptions, but they kind of prove the rule, right? And even if you're more experienced, it's like, look, if you're kind of doing VS Code data science, which a lot more experienced data scientists are doing, right? They're no longer in notebooks. A lot of them are coding in VS Code, and you're using, I don't know, GitHub Copilot, or you're using, Anthropic's Claude, or you're using Codex. Greg's point, and I think we all saw today, you piecing together all of the context windows and chaining together the context that's needed to prosecute a data science analysis correctly in code that way, it's going to take you a long time to get there. You're going to build this kind of, haystack of operations. God, Zerve's done a great job. It's doing a really good job. I think your time and iterations are better spent in a tool like Zerve than they are in trying to convince ChatGPT to be a decent data scientist.
Yeah, the thing that we've seen when we've kind of like interviewed our users is that the real power users tend to put an awful lot of work into building prompts. Like the first 4 or 5 user interviews that I did, I saw guys and gals pasting in like 2-page prompts into,
and like literally working with the GPT to write the prompt correctly, right? And building a 2-page XML bracketed prompt with, correct reason. Yeah.
Yeah, I don't know if that's necessary.
I mean, today you were not that, I mean, these were in well-intentioned directioned prompts, so they weren't bad prompts.
Yeah. Mm-hmm.
But they were definitely not 2-page prompts.
Well, I think the future of agentic coding is pretty exciting, and I'm excited to see how it develops. What's what's your closing remarks here? We'll let you wrap us up. Thank you for being here with us today. This was really
fun. Look, I've told you this before a few times, Greg. I am delighted with what you folks are working on. I think what you're doing is a real. It evidences a lot of craftsmanship to build something that is compelling to use, and what you all have done is that it's compelling to use. And I'll use the term and it feels lovingly crafted. This is not built by somebody who doesn't know what they're doing and hopes that it'll kind of work. It definitely has the flavor of Greg Mickelson written all over it that says, look, this is a job worthy of doing, and it's worthy of doing well. And I'll attest. And Greg doesn't want to be in charge of even his own code, thinking, how do I carefully partition this notebook into 3 things and ship it over? I think it solves a lot of the problems that you don't want to do, Greg. You don't want to be thoughtful about building a notebook, and especially careful and mindful of the DevOps who's going to inherit it. You just want to get something done and move on. And so Zerve does a lot of the dirty work, right? Making things a little cleaner.
Killer. Well, it's always fun to hang out with you, Gonzo, because you're always so complimentary. So thanks for that. I swear we're not paying him at all. I did not pay him this. I'll pay you after, Gonzo. Seriously.
Bourbon. I take payment in bourbon.
Yes. All right. Well, next time I'm in Salt Lake City, I'm going to drop by and we're gonna hang out and have a drink together for sure.
That would be fantastic.
Thanks for jumping on. Thanks for everybody listening. Feel free to send more questions in as you come to them afterwards through our Slack community. You can send them in through our website or anything else. We're happy to answer more questions. But I will close by saying you can get on Zerve and you can try it out. It's free to use. Get in there and send us your feedback. We'd love to hear what you think. Thanks, Gonzo. And we will sign out.
Okay.